Okay, let's get started. Good evening, everyone. So I'm very pleased to, that we have another UK Cloud Infrastructure meetup this evening, the third one this month. So I would like to thank everyone for joining us tonight. We have 23 attendees at the moment, and we have Ed Eastman, who is our speaker, you can see on the screen. Harriet Hadley will kindly organize the back end of this, and my co-organizer of the UK Cloud Infrastructure Group, Martinez, will join us as well this evening. So we're going to kick this off in just a moment. Just to remind you, if you're not yet on the UK Cloud Infrastructure Meetup group, join us this evening, please. We got a lot of events coming up in the next few weeks. So every Tuesday at the moment, there is an event in the evening. So if you're interested in these kind of topics, you're joined today, then please join the meetup group. And otherwise, for the event this evening, Ed is going to kick off the event in a moment and present us the companies he's working for, who he is, and what he's going to show us. Just for housekeeping purposes, please, there's a QA box on your screen where you can ask questions. And there's one question in there, which is probably a test question. Okay, no, the question is that, yeah, we're going to have a recording available after this, yes. Yeah, so please use the QA box if you have any questions. Ed is going to answer them most likely at the end. Maybe during the session, you will see, but definitely we're going to answer all your questions at the end. So please just pop them into the QA box, not the chat box. And then we're going through all of them at the end. So you get all your questions answered about what Ed is going to show us. So I'm going to hand over to Ed now, who is comes to us from NewDay, which is basically a credit card company. And some of you might actually be know NewDay, because if you have an Amazon Platinum card, you probably had some exposure to NewDay before. So it's time for you to now, Ed, to take over and show us what you have.
Oh, thank you very much, Daniel, and thank you everyone for joining. Yeah, so tonight I'll tell you a bit about NewDay, the company, what we do, and who we are. I'll talk a bit about our technology choices and the architecture that we've chosen. Describe one of our big recent projects, really key project for us, and talk about some of the pain points and the lessons we've learned along the way. Like Daniel says, any questions, pop them in the Q&A box and I'll answer them afterwards. So first off, a bit about me. I'm the Senior Manager for Platform Engineering at NewDay. So I look after our platform engineering team. So we look after both the kind of tools, processes and templates and patterns that our devs use for pushing our software into production. And also we look after the running applications. So we make sure everything's working properly and keep it running. I've been at NewDay for about 2 years. I joined in a dev role as a lead dev, moved into a management position, and now I'm looking after platform. Previous to that, I worked for Rackspace as a lead engineer, much more purely ops focused role there. So NewDay, we help customers be better with credit. We've kind of got two sides to the business. Our co-brand business, where we work with retail partners, like Daniel said, such as Amazon. This is really kind of a loyalty-based credit card offering. So you get points for spend on Amazon, you get vouchers for that to spend on Amazon. We've also got an API-based offering in this space. So AO.com, big online white goods retailer, they have used our credit APIs, integrated them into their basket, into their online checkout process, so customers can get instant credit to buy whatever they want from AO. The other side of our business is our own brand business. So we've got 4 own brand cards: Aqua, Marbles, Fluid, and Opus. Aqua's, I think, the biggest of those. And this really cuts to our kind of key ethos as a company. We want to help customers give access to credit where they might not necessarily be able to from one of the high street lenders. We want to encourage them into better credit habits, and we really want to give them access to better rates and a better credit history. So that's our company manifest. So it's something we take quite seriously. We do want to be a responsible lender in everything we do. So as a company, we're doing well. We're growing, at least before the current coronavirus crisis. We were growing 20% year on year. We've got roughly over 6 million cardholders. And our digital channel is becoming more and more important to us. And we recently got highly commended in the Computing UK IT Awards, which we're quite pleased with. And I think that's kind of an indication of how much we've changed as a company over the last few years. So about 3 years ago, we didn't have any in-house development capability at all. Everything was provided by third parties. So over the last 3 years, we've built up a platform from scratch. So all of our account servicing sites, our mobile apps, and our acquisition websites and APIs have been built in that time from scratch. And because of that, we've really got no legacy code at all. So everything is .NET, it's pretty much all .NET Core, and all straight into the cloud. And we chose Azure to host that. As a company, we also use AWS, but for our digital applications, it's all on Azure. And we made a conscious decision to exclusively use Azure PaaS services. So we've got no VMs at all managed by us in production. Originally, we started with a mixture of Service Fabric and Azure Web Apps, kind of with lots of Microsoft SQL at the back end. That's changed a little bit over the years, and I'll talk about that a bit more later. Obviously, as a financial services company, security is really important to us. And I think that cloud vision, sticking with PaaS services and truly kind of cloud native applications, means that the sort of traditional security approach of sticking your firewall or maybe 2 in front of your infrastructure, controlling access really tightly through that firewall, doesn't quite map necessarily to the cloud, and particularly when you're using PaaS services and sort of pure consumption PaaS services, it works a little differently, I think. So I'll talk a little bit later about how we look at security. So our tech stack, like I say, C#, .NET, .NET Core. We like to be on the latest versions of everything. On the front end, we use React and Angular, Swift, Kotlin for mobile. Our build pipeline at the moment is Bitbucket, TeamCity, Artifactory, Octopus. We looked at Azure DevOps a few years ago. It was quite immature then, I think, although it's definitely come a long way since then. But we decided to go with TeamCity and Octopus. It gave us the kind of features that we needed, and we've built a good pipeline on top of that. So we use Terraform to push stuff into Azure. So that Terraform's driven by Octopus. Our devs have templates. They can configure variables within Octopus pipelines that configure the Terraform and deploy different apps, different services out into Azure. Like I say, we've got a good story, I think, with automated deployments. We're in quite a good place. All of our deployments are fully automated, and we're really working hard to get all of our testing into the pipeline. We want to be driving towards continuous deployment, and that drive for I think we believe that deployment frequency of development teams is a really key metric. think it's generally agreed that the higher performing teams deploy frequently into production. We want to make that easy. We want to keep the kind of review and security aspects of that, but enable teams to really push stuff straight through to production in the future. Our model at the moment is that we want devs to own their own pipelines. It's something I feel quite passionate about. I think we've tried different models. There are different models out there where you have ops people embedded into dev teams, or DevOps teams that do the actual deployment stuff. I'm a firm believer that developers need to take some responsibility for that. I think you only get value from development when it gets into production, and so I think it's important for developers to take that ownership of their own pipelines. So our platform team support them. They come up with those templates and patterns, but developers deploy that software through to production. So let's talk a little bit about the architecture of our platform. Like I said originally, we started off with Service Fabric, app services, originally .NET Core, then .NET Core 2, Core 1, then Core 2, and at least trying to do microservices. I think what we found was that our original platform allowed us to build rapidly and let us get that kind of first footprint of our key applications for our customers to use. But Service Fabric never really worked that well for us. I think never felt we had that great observability into it as a platform. We've had problems with kind of scaling it. So Service Fabric runs on a VM scale set, and that scales in kind of hours rather than minutes. So it makes it a bit harder to deal with sudden spikes in traffic. It also doesn't really behave that what I describe as a true PaaS platform. So because of those underlying VMs, we've even had to do things like log into them in peak periods and disable Windows Update because it was using too much CPU. And as a platform engineering team, that's not what we want to be doing. I think it's obvious that you can do great things with Service Fabric, but I think you probably need a level of experience and a level of buy-in to it, size of environment, and kind of going wholeheartedly into it to really make it work. And for us, that just wasn't quite there. So a couple of years ago, we decided to shift to build on Azure Functions and more widely the Azure Serverless infrastructure. So .NET Core 2, 3.1 now. It allowed us to keep developing in the latest versions of .NET. There really isn't any operational support in setting up and maintaining those Azure functions. That the infrastructure layer is really hidden from us. The scalability of the serverless environments is very powerful, particularly when we look at some of those retail customers. It allows us to cater to unknown demand and ramp up quickly when we get that surge of demand, but also keep this kind of the cost savings when it's not there. We use APIM for our public API and endpoints, so that sits in front of functions and gives us a layer of security, abstracts away some of the difficult parts around certificate validation, that kind of thing, in front of our functions. For kind of web endpoints, we do similar thing with Azure Front Door. So that provides us with CDN, with caching, and with WAF functionality from a security perspective. Talking a bit more about security, we heavily used managed identities. Used to be MSI in Azure. So that means that each Azure resource we deploy has an Azure identity, a service principal under the covers. And you can use that identity to access other Azure resources. And that means that we don't have to keep passwords in config files. We don't have to worry about making sure that we're not leaking passwords out anywhere. And it's all managed by Azure, underpinned by OAuth ORDC frameworks. And when it works, it really is kind of seamless and works really well. Not all services in Azure support this. So we have to occasionally use Key Vault to keep those certificates, sorry, those secrets safe. But I think they're doing a good job of increasing the scope of that. And for some things like CosmosDB, you can do some clever tricks like accessing the Azure management plane using your service principal to retrieve the key that you then never have to store. For our kind of customer-facing applications, we use OAuth JWT tokens issued by our own IDP to keep that separation between our internal managed identities for our internal services and our customer identities. We still use mutual TLS for partner comms. I think it's kind of widely regarded as the sort of most secure method of doing that. In a lot of cases, we can abstract that away with APIM, but we also find something I'll probably touch on in the pain points a bit later, that certificates can be a real pain. So one thing I haven't mentioned is containers, and that's because we're not really using them. So containers is obviously something that's very hot in the industry at the moment. Everyone's talking about it, and I don't think I've got any disagreement that it's a really cool technology, and the things that you can do with Docker and with Kubernetes are really impressive. While we use Docker for some things in development, we're not using Kubernetes at all. And we have looked at it, but we've decided that for us, we don't think it quite fits right now. So particularly in Azure, the Kubernetes offering is quite tied to an underlying VM scale set, which means we're kind of concerned that we might have the similar sort of problems that we did with Service Fabric. I think Azure are probably recognizing that and trying to address it, but it still has that base cost, base VM scale set underneath it. I think even more than that, the amount of management overhead and kind of expertise you need to effectively run Kubernetes is quite significant. I saw an estimate online recently that the sort of year one cost of setting up and supporting Kubernetes was well over $1 million, and I can believe that. I think there's an awful lot of clever stuff in that space, things like Istio, some of the distributed tracing add-ons that you can put in, but you need the skilled staff, you need the people with knowledge of that infrastructure to build it and to curate it. So what we've done is said we're going to try skipping over containers entirely and see if we can build our platform on Azure Serverless, and I guess particularly from the compute perspective on Azure Functions. So let's talk a bit more about functions. So the kind of base functions are consumption plan. So that's really pure public cloud, limited control over what you do with them, and generally they work pretty well. So this is a kind of example load test we did just with a sort of moderate load. And you can see here that the average response time on these functions is really good. So it's a fairly simple function, not doing too much, calling out to a database, doing some transformation and returning a result, but those results are being returned average 141 milliseconds. That's kind of performance that we'd like. So from that point of view, it looks good. When we looked a bit more closely at this, there's a slightly familiar story to anyone who's used functions, or AWS Lambdas as well have similar issues. And that's this, there is a performance tail where the response times are much longer. And on Azure Functions, that tail is quite long and it's quite significant. So I don't know if you can see from there, but we've got a few results taking well over 5 seconds and one going as long as 15 seconds. And that might be fine for sort of batch processes, which I think is or offline async processes, which I think is originally how functions were envisaged to be used. But here we're trying to use them for much more than that, and for key functionality like making a payment on our website. We can't afford to leave customers waiting for 10, 15 seconds. We're going to time that out at the front end, and they're going to think it's failed, but it might still go through. So that kind of thing is a real problem for us. As a reaction to this, Microsoft brought out something called premium functions, I think middle of last year. So it's same underlying technology, but you get a pre-warmed instance. So you can, I guess the bit I missed in the last slide is that a lot of that bad performance is caused by cold start on Azure Functions. So that's where you scale out to a new function because of load, or because of, it might be your load or other people's load on the platform. And it takes a while to load up your function onto that runtime and get it running. So with premium functions, you get a configurable number of warm instances that run on top. So when you need to move to a new function because of the load, you've got a ready warmed instance ready to go, and it will start serving traffic straight away. There's a base cost to that. You can control it to a degree by configuring the number of max instances and the number of pre-warmed instances you want to run, and the functions will scale up automatically according to that. So this is a similar test on a premium function instance. You can see we've still got a few longer instances, but there's only 3 of them. And the longest of them is 2.5 seconds, which is significantly quicker than on consumption functions. And this really works much better for the scenario that I was describing. They're much quicker to scale, much quicker to start up, and seem to recover from any kind of hiccups much more easily. They also give you some important options around security. So VNet integration being probably the prime one there. So that allows you to keep your traffic within your own private VNet, connecting out to your database, other services, or potentially internal resources through that VNet connection. So now I'm going to tell you a bit about a recent project that we completed a few months ago, which is our new acquisition platform. So, bit of introduction, acquisition platform is a really core function for the NewDay business. It's the platform that allows us to acquire customers. So, mentioned earlier, we have about 6 million cardholders, or over 6 million cardholders, but we also acquire more than 1 million customers per year. And I think, in fact, we're the largest, we have the largest card acquisition volume in the UK. And that means that this acquisition platform is really, really key for NewDay's business. We're also one of the few providers that offer instant credit, or kind of true instant credit in the market, which means that there's some increased risks associated with that. So the platform itself has to take account of that. So about a year ago, we were in discussions with one of our partners who hosted our existing platform, and they told us that we really needed to move to their new version of their platform because they were going to decommission the old one in about 9 months. So after a few discussions and some toing and froing, we believed that we could build a better platform. I think the business has a drive for increased flexibility, availability, performance. And when we looked at the existing platform, when we looked at the fact that the the old supplier was telling us it was going to take about 2 years and cost some really significant amounts of money to deliver that, we talked to the business and we thought we could do better and faster. So we started off this project with 6 months till go live, and quite an aggressive timescale. So the platform has to accept customer data when customers put in their details to apply for one of our credit cards. We have to do a number of checks, call out to third parties, things like fraud checks, identity checks, the credit reference agencies to get a view on someone's credit history. And we take all that information, pass it into our decisioning engine, which looks at all of that data, looks at the rules that we have built into that, and then makes a decision and either hopefully onboards a customer, giving them kind of virtual card numbers potentially if it's an instant credit situation, or potentially saying no, we can't give you credit at the moment. We had a very clear need for dynamic scaling within this platform. We need, because of our clients, we need to handle peaks such as Amazon Prime Day or Black Friday, and so we really needed that scalability to work well, and to give us the ability to scale back and be cost effective. So our goal for all of this is 5 nines availability, and ultimately we wanted it to be able to run active across 2 regions. So this is a kind of simplified version of our platform, of our acquisition platform. So up at the front end, we use Front Door for our widgets, for co-brand acquisitions, and for our own brand acquisition sites. We have APIM that fronts up our co-brand APIs for customers such as AO. And then we have our core acquisition services. This is sort of the heart of the workflow that drives our whole process. It will call out to different connectors. Some of those call internal services, some of them are purely external, and those are separate Azure functions. And we wanted that separation, that clear separation, if you like, because we wanted to separate ourselves from some of the different technologies, maybe some of the mess in some of those third parties. They use lots of different underlying API technologies. I think we've got things like XML over HTTP, SOAP, JSON, and everything in between. Our database underlying this all is Cosmos, and we actually use Cosmos for caching on the connectors as well, where we want to maintain a cache of the data that we've just got, so that we don't have to do repeat requests out for the same data. And that acquisition database runs in active with multi-region rights, using the native Cosmos capability for that. We also have a number of internal functions that perform functions such as document generation, onboarding, looking up and performing operations on cards as part of that acquisition process. So this platform, we built it kind of very rapidly over 6 months. It's probably not perfect yet. We're improving it all the time, but it was delivered on time, and it is fulfilling its job really well now. With all of our acquisitions have come through that. We've had our first Amazon Prime Day through the new platform, and we'll hopefully soon be having our first Black Friday and Cyber Monday weekend, where we'll see significantly more volume coming through it. So some of the problems, some of the lessons we've learned, and some of the good things we found through this process and with this journey into using Azure Serverless technologies. So broadly speaking, functions are quite easy, and CosmosDB does work. I think there is less plumbing with functions. We've been able to establish some standards and templates to make it easier for devs to pick up, particularly around things like security, around reporting health out to other systems. They're particularly the consumption plan functions are really cheap to run and not to run. So that makes things like running multiple environments for testing, for load testing, for maybe testing a feature branch really easy. We can just spin up a separate environment, separate set of Azure functions, destroy them when we're finished, and the cost of that is really very, very small. And functions definitely do force you into separation. Because they are kind of small and independent, it makes you think about how you do that a bit better. I think generally we found that Cosmos works well. It's quick, and that key multi-region write capability is very easy, particularly compared to doing that kind of thing with SQL Server. I've used SQL a lot in the past. It's very powerful, and you can do a lot with it, but I don't think anyone would claim that running multiple SQL servers was easy. On the other hand, functions are definitely still quite bleeding edge. They're a moving target. DI kind of wasn't there at all initially. We had to rely on some open source implementations. When Microsoft came out with their new DI implementation, it had some problems. Things like logging didn't work that well. It's starting to settle down a bit now, but I think it's still not unusual for the functions team to make changes that require kind of more significant changes under the hood to your functions. MSI, Azure AD authentication can be a pain. It can be really hard to debug. I think they've made some improvements to that recently. So there's some really nice diagnostic tools now available through the Azure portal that allow you to go and see some of the reasons for failures calling your function, particularly if you're using the wrong token or token for the wrong audience or something like that. But certainly before that, it made it very hard because requests would just drop into a bit of a black hole and not show off in any logs anywhere. The functionality is also a bit limited. You can check whether a token is valid, was issued for the right audience in config in the runtime in the platform, but you can't do things like restrict to an Azure AD group purely through the platform. You've got to put that stuff into code. And with the current story on extensibility within functions, there's no really neat ways of doing that. Cold start, I think we talked about that. Even at consistent load, you see cold starts. So it's not just when you get bumps in traffic. The functions scale controller will bounce stuff around, and you have no control over that. You can certainly mitigate it with keep alives to some degree, but we've certainly found if you're trying to use functions for your whole application surface, there are some situations where that isn't enough, and you need to use either app services, functions running on app services, or premium functions. There are still some niggles around VNet integration. We found that if you have a source function that's VNet integrated and it needs to call another function that isn't, the allow listing rules on the destination function, even though it's not VNet integrated, need to allow the VNet specifically and not the IP addresses of the function. So some of that stuff is a bit counterintuitive and not terribly easy to get your head around. Talking about premium functions particularly, one of the problems we've had with them is that those standing charges that you have for just keeping that instance warm start to add up quite quickly. We've got well over 100 functions now, I think, in our infrastructure, and that cost is starting to add up. It's also not that obvious what scale you require or how the scale controller works. So some of those traditional metrics when you're trying to performance tune, when you're trying to size your application, do performance testing, things like CPU utilization and memory, those things don't always map that well to the way that the functions scale, and it can be difficult to size them appropriately, I think. There's other stuff like connection limits as well. And I think one of the problems that we found actually that caught us out slightly when we first moved to premium functions is that in the consumption function world, your application will restart fairly regularly. So if you're leaking a bit of memory, if you've got, I don't know, something that you're not quite tidying up properly as part of your DI setup, that probably isn't, you're probably not going to notice that in consumption functions. But if you move to an app service or a premium function, suddenly they're going to stick around, and you're going to notice if you're leaking memory. You're going to notice if you're not using things like connection pooling, and your connection limits. You're going to start running into things like connection limits, and that can definitely bite you. On the Cosmos side, I think Cosmos gives you guaranteed speed, but variable cost. And the upshot of that is that, you know, those big database writes that used to take ages in SQL Server might compete quickly, but they'll cost you quite a lot. And there's a few things you can do to help with that. So indexing policies, by default, Cosmos will index everything. You probably don't need that. So particularly if you're storing bigger documents, be careful of that. I think generally storing big documents you need to be a bit careful of because the cost is related to the size of the document. And there's a few strategies you can do to help with that, particularly if you've got a lot of data, but most of it's fairly static. Splitting out the variable parts from the static parts means that if you're only updating that small variable part rather than the whole document, that can save you quite a lot. Microsoft have brought out a couple of other options around the way that Cosmos scaling works. So Cosmos auto scaling, where you can set your Cosmos server to scale between a minimum usage and a maximum, which is 10 times the minimum, really improves the cost efficiency on Cosmos a lot, and allows you to run at a kind of sensible rate most of the time, but scales up very quickly if you need it. Microsoft are also coming out with what they're calling, I think, a true serverless variant of Cosmos, where you just pay for what you use. But that's not something we're using yet. I think it's still in preview. I think the other thing we've learned out of this, and it sounds obvious, but I think it's worth saying, microservices can be hard. You definitely do get some real benefits, I think, particularly around being able to scale out to different development teams, and scale out that responsibility within your platform. But it does come at a cost of complexity. I think it can be hard to get the balance on where you share your code. So you can end up with situations where you have a shared library which contains all the code, and your functions are just thin wrappers, and that means that you're not really getting that true interdependence. And if you're not careful, you'll get your distributed monolith. Yeah, and working out exactly how to do that layering between different functions or services is harder when you're splitting them out entirely. It's much easier to refactor that when it's different software layers. So, what's next for the NewDay platform on Azure? I think I touched on the cost for premium app services. Certainly something that we're keen to improve. One of the things we're looking at moving to in the very near future is a slightly different setup where we run multiple functions on a single premium app service, and scale that slightly bigger than the single ones would be. But that allows us to run a bit more cost effectively. If we run potentially 10, 15 functions on one slightly larger app service that can scale out, that should still give us the kind of neat separation between functions, whilst keeping the cost a bit smaller. Configuration is something that we're looking at really actively at the moment. So I think particularly with that drive towards continuous deployment, we need to be able to support scenarios such as canary deployments, stage deployments, A/B testing, that kind of thing. And so at the moment, most of our stuff is driven through Octopus configuration variables that get pushed into app settings or environment variables. And we definitely need something more flexible there. I think Azure Configuration Service is probably going to play a big part in that. We're just starting to use that now, and potentially some other services that are more clearly geared towards that A/B testing type scenario. GitHub Enterprise. So we were thinking about Azure DevOps a year or so ago. Microsoft bought GitHub and have more or less said that they're planning on moving most of that Azure DevOps functionality into GitHub Enterprise. So we're looking at that at the moment. We're looking at whether we can do what the kind of stuff we're doing in TeamCity and Octopus, and do it more efficiently, get some better functionality, some more streamlined pipelines with GitHub Enterprise. Maybe part of that, depending on how the timing works out. We're looking at Bicep, which is Microsoft's new kind of programming language on top of ARM for deploying into Azure. It looks like it's going to be really powerful, but it's at a very, very early stage right now. So one we're keeping an eye on. And kind of the last thing on there is in some ways a driver of the rest of it. So NewDay started out building this platform for ourselves. We've been really successful at it. We built a really outstanding platform in a really short space of time, and we found that other people are interested in that. So we're now in a position where we're growing to be a platform provider. We're going to take our platform, we're going to separate out the NewDay bits of it and offer it to other customers. And that's a really exciting time for us. It's exciting. There's some really interesting technical challenges of how we take what we've built and break it out for different customers. And it also changes a bit of the dynamic for us, particularly as technology professionals within NewDay. It means that technology is becoming the product rather than financial services, which is interesting times for us. So that brings what I have to say to you to a close. Have you got any questions?
Ed, can you see the questions on the Q&A box?
I can, yes. Okay, so do you want me to click that? Cool. So problems with Service Fabric. Some of it may have been down to how we're using it. I wouldn't rule that out. I think we've had problems with seeing what's going on in Service Fabric. We haven't found it that easy. Being able to restart services and things is quite hard. You can do it, but it's not super easy. We have I think that scaling part is definitely part of that. Scaling a VM scale set takes a while, and if you have an immediate performance problem because you've had a sudden spike of traffic, it's just too slow for that. And like I say, we genuinely have had to log on to Service Fabric nodes and kill Windows Update to alleviate some of that pressure in a sudden spike of traffic, and that's doesn't feel like like the dream of cloud computing, to me at least. Cool. So why didn't you consider Redis cache? We did, and we do actually use Redis in other places in the platform, particularly where we just want to cache. So I think Redis is really cool. It's another thing that we use the Azure Redis service. Generally, just works really, really well. In the acquisition platform itself, we decided to use Cosmos because we had it already there. Cosmos gives you some of the same benefits as Redis. It gives you that predictable, quick response. And when we were looking at that, it was kind of, do we want to introduce another technology, or do we want to use what we've got there already? I think if there was a compelling reason to use it, we would have done. But obviously, as you layer technology after technology into a platform, you can, if you're not careful, you can reduce the overall availability of it. So in the acquisition platform, is there any queuing of requests, or is everything direct and real time? Mostly it's real time. So we did look, when we were originally architecting this, we were talking about CQRS event-based patterns, but in the end, mostly we've gone with a more real-time approach, and I think that's because predominantly most of this is quite real-time. So where we have a customer, particularly on the API side of things, but I think also on the web side of things, they want a response quickly. If you're buying something on one of our retail partners' sites, you've been offered credit as part of the checkout, you need that to complete quickly. And while that isn't necessarily unachievable with an event-based architecture, it can get more complicated. And we just decided that for now we would mostly keep it real time. We do have queuing systems within the platform for stuff that is more asynchronous in nature. We've got mostly using Azure queues rather than Service Bus. Again, I think Service Bus feels like a bit of a pre-cloud technology in a lot of ways, and not saying that you can't do brilliant things with it, but we found most of the time Azure queues, if you need to do that kind of stuff, work quite well for that. What's the average size in number of lines in the functions? I don't know, is the honest answer to that. I'd have to have a look. Mostly, I don't think they're too big. But there's probably a couple of bigger ones. I'd have to have a look. Sorry, I don't know that one. Do you use any kind of observability pattern? I'm not too sure if I can answer that properly without knowing a bit more about what you mean by an observability pattern. I don't know if you can easily type some more or ask some more details on that. I think we have kind of health check endpoints throughout our systems. If we want to check the health of a system, which we'll check kind of connectivity to different underlying systems, that kind of thing. I guess potentially I'll answer that and answer part of Martinez's question on what monitoring and alerting are you using. So we really heavily use application insights. So App Insights integration with Azure Functions is really seamless. It's not hard to add it, and it's kind of easy to add in good logging around different functionality. So for instance, logging dependencies through App Insights is really, really easy. And we do that extensively and use that to to monitor for problems and to look for performance improvements. I guess on the monitoring thing, we're also starting to use Grafana more and more. So App Insights for looking into a problem is really good, is really powerful. The dashboards as part of App Insights, I'm not sure are that great. And I think we're plugging Grafana directly into Log Analytics and starting to use that more and more. It's a bit more powerful. It allows you to be a bit more flexible in the way that you develop those dashboards. But the pure alerting is currently still through Azure Monitor. Do we use durable functions? Yes, but not in our acquisition platform. So we've got a couple of slightly more long-running bits of functionality where we are using durable functions, but within the acquisition platform right now, we're not. In terms of cost comparison, would moving to AKS cluster have worked out more cost efficient? I don't think so. I think the overhead of supporting AKS would have been quite significant. I'd be surprised if it was more cost efficient overall. In terms of the raw resources, maybe, but overall, I doubt it. I might be wrong, but I think that's my answer. If you're planning to use Premium Function or ASE, why not use AKS with ACI? I think when we started with functions, AKS with ACI was a bit more limited than it is now. I think even with if you're using ACI, you still need that that base scale set. And I guess there's probably a bit of a sort of a bit of an approach or philosophical element to that, where if we kind of took that dive to move straight to serverless, and yeah, containers can solve some of the problems, but they also introduce others around. You are still running a small VM, and you are kind of responsible for using it, updating it, all of that kind of stuff. Obviously less than traditional VMs, but also more than if you're using functions. Is managing scaling functions different, having individual points of management rather than orchestration layer? I think it might become more difficult. I'm not sure that we generally have that much of a problem with it right now. So I think we might end up looking at, there's either a danger or a potential, depending on which way you look at it, that we might end up starting to build a bit of an orchestration layer on top of Azure Functions. Right now, I don't think we have a massive amount of pain where on a daily basis, we're kind of fiddling with the knobs on dozens of different functions to get the scaling right. I think we can, by and large, set the minimums and maximums quite sensibly, and let the functions runtime deal with the rest of it. As we grow, as we do this more and more, as we want to improve our cost efficiency, particularly as we're doing this for partners, then maybe. Monitoring and logging stuff. I talked about this a bit already. Pretty much App Insights, alerting based off that. If you've got any other specific questions that I didn't touch on earlier, then please add it in. Programming patterns. I think I'm not sure if I've got a good answer to that. it's probably a few different patterns within it. I think generally we're using more kind of more command-based, not command-based, more less sort of CQRS type stuff. But beyond that, I'm not too sure. Do we use Event Hub's Kafka? Not currently within our digital infrastructure. So we have a separate data science department. They've built a kind of data lake and data science environment on AWS. They do use Kafka within there. We're looking at whether we can do some neat stuff integrating with that via Event Hubs, but right now we're not using that. Use of Terraform in the architecture. So we use Octopus. Octopus calls out to Terraform. So we have Octopus templates that are configured via variables in Octopus. So we'll say, you know, I want an app service, and then that gets pushed into a Terraform layer that builds out, does the Terraform plan, and then gives it back to Octopus to do the actual deploy. So we're storing state files. We're using Terraform to do the actual deployment, but it's driven by Octopus. Would you change anything if you had to implement the system solution again with lessons learned? Probably. I'm not sure. I think I'd need a bit more prep to answer that really well. I think we probably with hindsight we could have done more to flesh out the templates for developers within functions to make some of those patterns around things like logging, things like requests, retries, around security certificates. I think we probably could do a better job of doing that. Particularly things around certificates. I think it's something that we will be changing, hopefully in the near future. Managing certificates, I think, in any environment is a real pain. And in the financial services industry, you have to manage a lot of certificates. So one of the things we're planning on doing is building a service on top of Azure to handle certificates. So at the moment, mostly certificates are stored on app services or Key Vault, but you then can run into real problems where you need to rotate a certificate. You're not quite sure where it's used. You need to change it in lots of different places. There's lots of nuances in how people implement things like mutual TLS authentication, and we definitely want to build some libraries, some patterns, and I think ultimately some services on top of Azure to make that much easier for our developers and for us as a support team. I kind of dream of being able to update a certificate in one place and have it dynamically updated across the platform is something that we want to get to. Did we consider AWS instead of Azure? Almost certainly, yes. I think that decision was probably made before I joined NewDay, so I'm not quite sure what the deciding factor was. I think the people involved at the time were more specialised on the .NET side, and I think it was kind of a natural choice to go with Azure. I've used AWS in the past. I think it's certainly as powerful as Azure. I think some of it's not as easy to get your head around. The two platforms are evolving so quickly that there are different good points and bad points on both. How often do we use versioning on functions? That's a really good question, and it's probably another one of the lessons learned. I think not that often right now. Some of our core functions we've been quite good at saying, trying to keep those contracts backwards compatible so that we don't have to version one in that acquisition platform. I think we sacrifice some of that for speed of delivery. and that's something that we're looking at improving now and getting some better patterns around how we version it. PubSub, I think I probably touched on this a bit before. We're not using that much PubSub. Like I said, more for simplicity and keeping the real-time parts of it. We do use it in places. We have some sort of notification things where we send messages out to partners to tell them about what's happened with an application. And we do use PubSub for that. We use, I think, either event Azure Queues or what's it called? Event Service Bus and functions triggered off that. That works quite well. But yeah, there's bits of it in the platform, but it's not a fully kind of PubSub event-driven platform. Which language? Pretty much exclusively C#. I'm not sure. We obviously have JavaScript developers on our front end. I'm not sure I've ever been asked if we could have a JavaScript function. I don't see why we couldn't, but generally they perform well. I think we've not had any kind of performance problems with C# and functions beyond that kind of cold start problem. Once they're up and running, they perform pretty well. We've not had a problem with that. Why Kafka on AWS and not Databricks on Azure? I don't know is the honest answer. I think the data science team chose that. I think they're more familiar with that kind of data science Python environment, and I think AWS is probably the more natural choice. Whether it's better or not is a different question. But yeah, I'd have to ask one of those guys that. Sorry. What did the project do to security test the new platform? We've got kind of a number of layers of security testing. So we use SonarQube and Veracode to do SAS testing. So we run SAS testing on every build. We raise defects off the back of that. We turn our builds red off the back of that. Once a release gets through to our UAT environment, we run DAS testing against it. So I think that's also a Veracode product. So that will do things like throwing silly input at functions, trying to exploit any vulnerabilities like cross-site requests, scripting type stuff, or bad input validation, SQL injection, all of that kind of thing. And before we go live with anything, we do an external pen test. In fact, we're now using a kind of continual pen testing service where we expose our UAT environment to testers. They go and run tests on a continuing basis against it.
Ed, just to let you know. Oh, and he's jumped off. Oh,
I dropped out.
No, you froze for a bit. So could you repeat that last question? I think it froze for everyone.
Sure. So long-running, what was it? Long-running operations. We don't really have any in the acquisition platform except for that notifications bit where we use PubSub. On the wider platform, there's a couple. So I think balance transfers is something that takes a while to go through, and we use durable functions for that, and generally that works quite well for us. Do you test contract? Do you use packed contact testing? Not right now. It's something that I've looked at. I thought looks really cool, and I think we've got a few people who are keen on doing it, and I certainly see the benefits of it. But right now we're not using it. What CosmosDB API do we use? We are just using the SQL API at the moment. I don't think we've had any kind of use case where we needed to use the Gremlin or Mongo APIs. So it is all Cosmos, all SQL rather at the moment. Cool. I think that's all the questions. Unless anyone's got any more. Okay, cool. So just to close off, if you're interested in joining us, like I said, we are hiring, we're growing, particularly as a result of that really interesting project around extending our platform. So if you are interested in joining us, take a quick pic of that QR code. That should take you through to our hiring pages. If you've got any questions, comments, if anything you'd like to ask, feel free. That's my LinkedIn. That's my Twitter. I'm not
Ed,
terribly good at social media.
Sorry, Ed, you're not actually sharing.
Oh, I'm not sharing. Sorry. Thank you.
No worries, but I think there's been so many questions, and thank you everyone for joining. Yeah, it'd be great if you can get your contact details, because I'm sure there'll be a couple of people on the call that will want to continue the conversation.
Cool. Is that up there now?
Yeah, it is. Thanks, Ed.
All right, cool. Thank you. Yeah, so there's QR code. That's my LinkedIn. That's my Twitter. I'm terrible at social media, so I don't really say anything much on there, but you're welcome to ping me on there if you'd like to. And thanks for the comments. It's good to hear. Glad it was interesting.
Fantastic. Thank you so much, Ed. Daniel, do you want to close?
Yeah, sure. Thank you very much. Thank you so much, Ed. It was a really great presentation and a great insight into why you guys went straight from your basically third-party legacy platform into serverless and skipped containers and all this stuff. It was really, really a great presentation. Thank you so much. And also thank you to the attendees for the great questions as well. Some very insightful questions as well. So
absolutely
great, yeah. So once we wrap up